Hello, good evening, everyone.
Good evening, sir.
Yeah, good evening. I hope you are hearing me loud and clear.
Yes, sir.
Okay, so today we are moving into another course, INS 841, quantitative techniques as applied to risk management and insurance. The course is largely the application of statistical techniques to insurance and risk management. So we'll largely be taking some of the statistical concepts and methods. So today we'll be starting with inference, and our basic concepts in inference include sampling distribution, and hypothesis testing. Inference is about generalizing results that is obtained from a sample on the entire population. It's also about testing the truthfulness of claims made on a population based on sample values. Inference can also include probabilistic investigation, uh, model building, and time series analysis. So we shall cover the following. Of course, basic terms and sampling and sampling techniques, sampling distribution and hypothesis testing in today's class. Most of the concepts are brought from the textbook Statistics for Business and Economics by Anderson, Sweeney, and William. This textbook, the soft copy, had been shared with us earlier. So you could also complement this material with any other textbook of your choice. At the end of the topic, it's expected that you understand the concepts used in sampling, the reason why certain sampling techniques are adopted, should be able to implement the sampling techniques that will be introduced. It's expected that you should be able to derive the sampling distribution of sample means and able to test hypotheses. Some of the concepts that we'll be discussing today are not necessarily going to be new, because majority of us finished from Faculty of Management Sciences or Faculty of Social Science, where basic statistics were introduced. But we'll just go through the concepts again, just to serve as a reminder or as a revision. And then we'll start using those concepts after this basic introduction. The first concept is population. Population. Most times people think population actually represent the number of people. But in actual fact, population simply means the collection of all specified type in the target universe. It's the putting together of a unit of interest in a space. So the population is not necessarily the number, but the number of the unit that you have put together is this population size. But most times people mix, population size with population itself. So I can have population of insurance students. I can have population of postgraduate students. I can have population of students generally. So once I defined clearly the units that I'm putting together in a defined space, then I have my population. Population size, on the other hand, is actually the size of those units, the number of the units that should gather together in that space. So sample is another term. Sample is a fractional part of a population. Sample is a subset of a population. So if I have the database that contains the demographics of policyholder, and that database has detailed information on about 200,000 policyholders. So the database itself is the population of policyholders. And of course, the size is 200,000. So if I want to carry out a study to investigate the recent trend in claim size, be for a particular line of business, and I know that I don't have the resources to study all the 200,000 data points. So a sample have been selected, a part of it have been selected. So the numbers of policyholders that have been selected, or the policyholder selected for the study, would be my sample, while the entire information in the database is the population. So sample is a fractional part of the population. This is a subset of a population. Is there another parameter? So a parameter is a function of all the units in a population. So if what I'm interested in is the average claims ratio, you see, I will have claims ratio for each of uh, the policyholder, and what I'm interested in is the average for the entire um, um, database. So if I compute that, whatever I get as the average claims ratio would be my parameter, because it is a function of all the units in that database. So the parameter is a function of the units in a population. I might be interested in the average age, of the policyholder. I might be interested in the average premium being paid. I might be interested in whatever, information beyond the ones that we have treated. So as long as that information represents every unit in that population, then that is my parameter. So a parameter is a function of all the units in a population. We have statistics. I'm not talking about a discipline now. I'm not talking about a subject. In fact, I'm talking about a plural of statistic. So a statistic here is a function of all the units in a sample. So just as you have parameter representing the function of the unit in a population, a statistic is a function of the unit in a sample. So I can have sample mean, can have sample variance, I can have sample standard deviation, sample proportion, and so on. What it simply means is that I have my population and I've taken part of it. Now, the part that I've taken, any function at all that represents everything, every unit in that part is my statistic. So if you have several of them, then you have your statistics. Not the statistics as a body of knowledge that deals with how data is collected, analyzed, and presented. But statistics here is the plural of statistic. And another term that we commonly use is estimation. You see, the whole essence of trying to take sample, observing it, generating results is actually to estimate. You don't have detail of the information that you require, and you needed data to guide that, you guide your knowledge about that required information. That's the estimation, the process that you go through to calculate that required information is estimation. So you can select a sample from a population, observe it, generate your results, and in that result, you expect it to reflect the population from where that data is collected from. The whole process of coming up with a result that is representative of the population and also meet your requirement, the whole process is estimation. Estimation. So when you go through the whole process, you arrive at a result. That result is called the estimate. Estimate. And of course, the formula that you use in generating the result is known as estimator. Estimator. And of course, from the beginning, we have said you have a population which is the aggregate of all the units, interested units that you have put together. And you have sample, which is the subset of that population or the fractional part of it. Now, how will you select that fractional part, that sample from the population? The process of the selection is called sampling. Sampling. So a sampling or sampling is a procedure of selecting sample from the population. Now, when you are attempting to select from a population, you might need a list of all the units in the population from where you are selecting from. That list is what is referred to as the sampling frame. So a sampling frame is a list or a map or any other acceptable material from where sample can be taken. So basic terms that we commonly use in our competitions. Now, when you are selecting sample from a population, the sampling procedure can be probability based or non-probability based. When we say probability based, it means that your selection is done with the use of random techniques, with the use of chance mechanism or probability theory. In your selection, you might do it in such a way that all the units in the population are equally likely of being selected. And you can also do it in such a way that all you are interested in is just to ensure that major groups in the population are represented. You are being subjective. So in the first instance where you want to assure that all the units have equal chance of being selected, you are introducing chance, you are introducing randomness in your selection. So that is probability sampling. But in the second instance where your interest is just to ensure that major groups are represented, then that is non-probability sampling. So those are the two types of sampling that you can have. Remember, we started with the basic term, population, sample, parameter, statistic, estimation, estimate, estimator, sampling, and sampling frame. We said population is the aggregate of all the units of a specified type in a target universe or in a given space. Sample part of a population. Parameter is a function of all the units of the population, while a statistic is a function of the units in a sample. Estimation is a procedure for calculating the value of the unknown population parameter, while estimate is the value that you arrived at after the estimation exercise. The formula that you used in your estimation is called the estimator. Sampling is a way of selecting part of the population, selecting sample from a population, while a sampling frame is a list or a map from where sample can be taken. We have also discussed the types of sampling. We have said that our sampling can be probability based and it can be non-probability based. When it is probability based, it means that you are making use of chance mechanism, random techniques of probability theory in your selection. While the sampling is non-probability based, if you're not making use of any of those three, but you are being subjective in your selection, or just trying to satisfy some major interest. So now we take each of the sampling technique for our discussion. So the first one is the probability-based sampling, the one that involves the use of sampling technique, chance mechanism, or probability theory, starting with the simple random sampling. Simple random sampling. So you have the database, and you can query that database. And your interest is to ensure that any point, any either individual, subject, that represents the unit of measurement can be selected. You arrange your sampling in such a way that any of those data point can be selected. Then you are implementing simple random sampling. Simple because every unit have equal chance of being selected. Of course, random simply means you are not being subjective in your selection. So when you have a sampling technique in which all units are given equal chance of being selected in the sample, then you are implementing simple random sampling. So the major advantage of it, the way it is explained, is that it is very easy to execute. You don't need any experts knowledge, in its implementation. As long as you identify your population, then you just do your selection. And then what you have is your simple random sample. However, as easy as it is, it has a major shortcomings. Because you are selecting in such a way that every unit have equal chance of being selected. So you are assuming that the characteristics of interest in that population is homogeneous. Every unit has some level of the characteristics of interest you are measuring. You don't expect to be heterogeneous. So when the population is heterogeneous, then you have difficulty. When the units are not the same, then you have problem. Because you might end up selecting only same group as your sample and leaving out other groups. So in that case, your selection will be biased because you have not put into consideration the knowledge, the background knowledge of that population. So that's what simple random sampling is about, the advantage and disadvantages. So the second one is the stratified random sampling. Stratified random sampling. So in this case, the population is first divided into major groups. It is from each of the group that you will select your simple random sample. Is someone trying to ask a question? Can you hear me?
Loud and clear, sir. We can hear you.
All right. So I thought I heard someone trying to ask a question. But meanwhile, in the chat area, please ensure to type your name and matric number as a way of capturing your attendance. So we are back to the stratified random sampling. So I was saying that under the stratified random sampling, the units are first grouped together into homogeneous group. You group them together. The similar ones will be put together. It's like having a database of so many insurance policies, and then you have not decided to group them. You can have motor, in fact, even the motor, you can have comprehensive and third party, or third party plus, or third party plus plus, and so on. So you you have them modeled up in database, but so assuming you insist on separating them such that you have motor comprehensive, you have motor third party, okay, you can have motor third party plus, and so on. And you want to um, investigate the trend in, say, claims ratio or number of claims, for instance. So if you lump them together without profiling them into the types of policy, you might have a misleading result. So in order for you to have a clearer picture, you have stratified that database such that if you want information about um, uh, those with comprehensive, you can easily select from them. Those third party, you can select from them. The third party with some variation, you also can select. So if you want to have an idea of the average, the trend, so you can select part of the third party, part of the third party plus, and then part of the comprehensive. So we put them together, that should be a representative of the population that you have. And that's the idea behind the stratified random sampling, because we want to ensure that the major groups are represented, and at the same time, you want to implement chance or randomness in this selection. So we define stratified random sampling as a probability-based sampling in which the population units are first divided into homogeneous groups, that is called strata, and then from each of the stratum, simple random sample are selected. So you are still going to implement simple random sampling in your selection anyway, but you're just being careful to ensuring that the population are well disaggregated before selection is done. So if you look at the definition, you can easily identify the benefits, of implementing such. Number one of the benefits is that the the data that you get will be a better representative compared to simple random sampling, especially when the population is heterogeneous. But the major disadvantage is, so because you need to divide the population and then select from each of the groups and so on, implementation will not be as easy as simple random sampling. So level of expertise will have to be involved, because stratification might not be as straightforward as the example that I've given. So stratification might require some, high technical skill in implementing. So that's why we say that it's in terms of implementation, it requires higher level of skills. Since I'm going to involve experts, costs, will come in, because the experts don't come cheap. So, but that's stratified stratified random sampling technique for you. So the next is systematic sampling. Systematic sampling. So it's another probability-based sampling. But in this case, sampling or sample are selected at regular interval. So you can be at maybe two steps, or at three steps, or at whatever steps away. So all you need is just to know the starting point, and then the rest will be automatically being generated. So let's assume that I have a database with 100 units in it, and I want to select maybe a sample size of 5. What systematic random sampling says is that you have to calculate the sampling interval. Okay, at what interval will you do your selection? Yes, we are aware that you have 200 units in your database. That's the population size, but you desire 20, okay, out of the 100. So what interval should you do your selection? The sample interval will not be capital N all over small n. Capital N is 100. The desired sample size is 20. So if you divide 100 by 20, you will have 5. And what that simply means is that you should select at 5 interval. So if I select number 1, the next will be number 6, the next will be, number 11. And so I'll just be adding 5 to it until I get to the last number, maybe number 200. So that information that I eventually get will be my systematic sample. Sample. So it's easy to execute, but once you know the starting point, the rest will be easily derived. So it's easy to implement, and it's straightforward. So the challenge is, if I have a population of 100 and I have a sample size of 20 to collect, and I've calculated my samples, the sampling interval, which is capital N over small n, and I got 5. So the challenge usually is, where should you start from? So the starting point is called the random start. The random start. The random start is any number between 1 and your k. Number between 1 and k. So in this case, our k is 5. So your starting point will be any number between 1 and 5. So we are doing this because we want to remove any form of bias in our selection as much as possible. So the random start will be any number between 1 and k. So in this case, our k is 5. So any number between 1 and 5, that is the starting point. Then the rest, you will be adding 5 to it. And once you get to the last number, what you have selected are your sample, but they are selected using systematic sample. So the benefit of it is that it is very easy to execute, especially when you know the starting. The rest, you just be adding sampling interval to it, and it's straightforward. But the disadvantage is you might not get a unique result, especially when the sampling interval is not a whole number. So if I'm to select 20 observation from 100, that's straightforward enough. To get my sampling interval of 100 divided by 20, and it gives me 5. There's no whole number there. But what if I want to select 21 data point? So if you divide 100 by 21, you won't get 5. You get something close to 5. And the challenge is, should you round up or you round down? If you round up, the result that you will get will be different from you rounding down. And that's a big challenge for that sampling technique. So we have discussed simple random sampling, which is the sampling procedure that ensures that every unit has equal chance of being selected. We have also discussed stratified random sampling, which involves dividing the population into homogeneous groups first. Remember, homogeneous simply means the units are as similar as possible. So when you select homogeneous, when you group a population into homogeneous units, and then from each of the units, you'll be selecting your sample. So when you put all the samples together, they give you a true reflection of what that population is. And then finally, we discuss systematic sampling, where units are selected at regular interval. So the interval is what we have calculated as capital N over small n. That when that interval results to fraction, then implementation becomes clumsy and not as straightforward as we would have desired. So the next one on probability-based sampling is cluster sampling. Cluster sampling. So cluster sampling also involves some grouping. You know, under the probability, under the stratified random sampling, units are divided into groups, and then the groups, from each group, you select your sample. Under cluster sampling, units are not being divided. Units are being formed by bringing them together. So they actually come together, not that you are dividing them. They come together to form clusters, to come together, to bond based on their geographical proximity. So units that are very close to each other will be grouped to form clusters. So it is one of the two-stage sampling. So in the first stage, the population is first grouped together. And then in the second phase, those clusters that you have formed, you will now select either one or two at random. So in this case, you are not selecting the units at random. You are selecting clusters at random. Under the simple random sampling, it is just the units that you select directly, and then you have your sample. Whether it's stratified or systematic, you are still selecting, and it is the units that you are selecting. But under the cluster sampling, it is the cluster that you are selecting. So your units have been grouped together to form clusters. It is that cluster that you have formed that you select at random. Because the principle here is that you want to assume that clusters are as heterogeneous as possible. That means every cluster exhibits a major characteristics of the population. So it is a cluster that is select at random, and then you have a representative of the population. So it's very straightforward and easy to implement. So the next is non-probability based sampling. Non-probability based sampling. So we have said that probability-based sampling involves the use of chance mechanism, probability theory, or random techniques in our selection. And we have discussed different types of probability-based sampling. But under the non-probability-based sampling, selection is not done with the use of random techniques. Selection is not done with the use of chance mechanism, but selection is done in such a way that groups are represented, or select from where you have most information. That's objective. And then select even when the population is hidden. So let's look at the first one, convenience sampling. Convenience sampling. So I have a survey to do. The survey is about NERA, and I have chosen custodian as my study area. So I equip my researcher to do the selection, but because either the parents of the researcher or the spouse or there's some special relationship, the researcher was able to have access to to custodian and then did the survey. So in that case, sampling is done because of accessibility. It's not done because you are selecting at random or you grouped or you are selecting at regular interval. You went there because you are sure that you will have access to the information or have access to those that will respond to you. So when you do your survey because of accessibility, then that sampling procedure is convenience. Convenience. So convenience sampling will require you getting information from where you have access. Purposive information, on the other hand, is selecting information from where you have the most information. It's not based on accessibility. It's based on the availability of information and special privileges. So purposive sampling is a non-probability based sampling. So in which sampling is done from where the researcher has the most information. Okay, there is there's a grant that is being given by NICOM, for a competition on maybe in the NERA Act. We're trying to project and forecast the effect of the NERA implementation on Nigerian economy, and they have asked insurance company to come and enter for that competition, and they stand a chance of winning maybe $100,000 or whatever. So if you are sending in someone to represent you during the debate or during the presentation, you have to select that staff that you know is very, very eloquent, not a stammerer like me, not someone that picks his word one by one. You look for someone that can talk maybe 30 words per second and so on. And at the same time, is very, very eloquent. So that is selection based on information. But the individual that you put forward will have to meet those criteria. So that is not selection at random. You're not selecting any worker at random. You select those that have that criteria. So purposive sampling is about selection with knowledge. Select from where you have the most information. Quota sampling, on the other hand, is very similar to stratified random sampling. Because under quota, your interest is to ensure that major groups are well represented. Under quota, you are selecting sample to balance the major groups in the population, to select sample to assure that the major groups in the population are well represented. You are not using any randomness, and that's the difference between quota sampling and stratified random sampling. Under stratified, even after grouping, you need to apply the simple random sampling in each of the group, and that's where the difference is. Under quota, you're not using any random technique. Okay, but the two of them tries to assure that the major groups are well represented. The last one is the snowball sampling. Snowballing, or sometimes called network sampling. This is where a unit of a population is used to generate other members of the sample. And it's mostly used when you have a hidden population. Hidden population means a population where you don't have their list. How many billionaires do we have in Nigeria or in Lagos? You don't have their list, but they exist. But it's very likely that billionaires are friends to billionaire. So if I'm to study billionaire and luckily I got access to one, that one will lead me to the others. And that other will also lead me to the others. And before I know what is happening, I can use that network to get the population or the units that I desire to study. You can also use it to investigate people with risky behavior, like those that are involved in drugs, or they are involved in other shady activity. So you use the principle of birds of a feather, will flock together. So if you get one, you use a lot of incentive, and then you will have access to the other ones, and then you conduct your study. So that is snowball sampling or network sampling. So they are all easy to execute. Everyone has advantages and disadvantages, and so on. So that is probability sampling for us. So I want to take your question, if you have any, before we move on. Do we have questions or clarification that you want me to make?
Okay, so please, my question is on the quota sampling. Please, can you throw more light on quota sampling? Thank you, sir.
Okay, so quota, just as we run our political system, or even our governance generally, administration in Nigeria is based on a quota system. Our employment, representative, is based on quotas. Quota here is trying to assign numbers to major groups in the population. And then when you are selecting, you select in such a way that once a group have exhausted their number, you stop selecting from that group and you go to other groups and select until they exhaust theirs. So you are making sure that all groups are represented in your sample. So that's the idea behind the quota sampling. It's a non-probability based sampling that assure that the major groups in the population are well represented, but you're not applying any chance, any random or any probability theory in that selection. Uchenna.
I don't hear you.
Uche now.
Sir.
Can anybody hear?
Hello.
Hello, go ahead, ask a question.
Okay. Sir, my question, or rather a plead. I don't know whether small, will I say, as in we use figures, maybe you bring small example, especially in the other slide, probability-based sampling, so that you can explain using numbers. Maybe we already have a data, then
Yeah.
you explain using that data.
Yes. Yes. So before, in it's just like someone that is trying to teach case study. Case study solution to case study will have to rely on some domain knowledge. So if the domain knowledge is not there, you won't be able to grasp, the solution that is being proposed, for the case. And that's exactly what I'm doing. Before you implement, explain the concept. So once we explain the concept,
Okay.
then I will now show you how to select sample in Excel. I'm going to implement all of this in Excel. So where I will have a sample, I'll have data, and I would use my Excel to select simple random sample. I will use my Excel to select systematic sample. Did you get it? So if I say, oh, this is systematic sample, you will understand it because I've explained it in theory. So we are explaining all of those now. And like I said at the background, that I expect that all of you finished from Faculty of Management Science, or you finished from Faculty of Social Science, or those that did economics. And that at undergraduate level, at one point or the other, you are done statistics. So, and that is what we are relying on. Because my job is not to teach statistics. It's just to apply that thing that you have learned. But we're just doing a recap of all of those before we're going to apply. Our teaching will be based on the use of Excel only. And we shall get there. Don't worry.
Thank you.
We will use figure. I think that answers your question.
Yes, sir.
Yes, we use figure. So let's continue. Now, when you select your sample, so you remember we're actually trying to make inference. And it is a process of inference that you need this sampling, the database is so huge. You can't work with all the data points. So just needed to select a sample from your database. It is that sample that you want to use to estimate, what you're interested in. And then once you go to estimate, you'll now be able to make an inference, generalize, so that for decision making and so on. Now, while you are, making an attempt at collecting the data, generalizing it, summarizing it, and generating your results, there are two types of error that you're liable. You have sampling error, and then you have non-sampling error. Now, the sampling error arises as from the use of inappropriate technique. such that you have arrived at a result that is at variance with what is expected. Then you know that your, sampling, error, your result is filled with sampling error. Any error arises as a result of the choice of sampling technique is sampling. While other results, other error that is not as a result of your sampling technique, some error in transcription, error in measurement, even the way your questionnaire was designed, maybe the error in your command, and so on. Those ones represent non-sampling error. So you can imagine if I hand over a questionnaire to you, and because we are used to answering questionnaire with, for under gender, where you have 1 for male, 2 for female, and that's what you are used to. But I gave you a questionnaire in which I had reversed it. I made 1 to be female and 2 to male. I handed it over to you. But because you are used to 1 male, 2 female, and then you ticked the wrong option based on your past experiences. The wrong option is an error, and it's a non-sampling error because you are selecting the wrong option at that instance. So it's a non-sampling error. It's not because you have chosen the wrong sampling technique, not because you adopted whatever sampling technique you adopt, but because the individual that is filling the questionnaire has filled it wrongly. Okay? Someone that is between ages 20 and 25, assuming you have that in your questionnaire option, and is taking ages less than 18. So that is an error, of course. And that error is a non-sampling error. It is not as a result of the sampling technique that you have chosen. So, as much as possible, those 2 errors should be minimized, for you to have a reliable estimate for your estimation. So, why do you take sample? Why didn't you study the entire population? Cost consideration is a major point, major reason. Speed, the time that it will take for you to generate results is another major reason. Accuracy, because if you deal with sample, you are likely to be more accurate than dealing with the entire population. It gives you that opportunity of greater scope, and of course, can get further information. So now let's look at different scenarios when you select one sample from a population. So the population has capital N as its size, and then you are selecting a sample of small n from it. When you're selecting your sample can be selected with or without replacement. With replacement here means when you take a selection, observe, or you take another one, that selected unit is returned back into the population. So it's also available for the next draw. That is sample or sampling with replacement. Why is sampling without replacement? It's about selecting a sample observing it, and that sample is not returned back into the population before that ones are drawn. So, for instance, the population size is reducing when you are selecting without replacement. While when you are selecting with replacement, the population size remains constant. After all, when you select, you return it back to the population before subsequent ones are done. So, when you select a sample size from a population with replacement, the number of possible samples that you can get is small n to power of small n, capital N to power of small n. While if you select without replacement, it is capital N combination small n. You must have done this before. Now let's look at this example with some figures now. I have a population that has 5 units. So the units are 6, 8, 10, 12, and 14. And I wanted to select a sample size of 2 from this population. So how many possibilities are there if I'm to select with replacement or to select without replacement? Okay. Now let's look at with replacement. With replacement, there are 25 possibilities. Capital N to power of small n. Capital N here is 5. The desired sample size is 2. So if you raise 5 to the power of 2, then you are going to get 25. That means there are 25 possibilities. If I'm to select the sample size of 2 from population size of 5 with replacement, and what I have here are the possibilities. If I select 6, I return it, I could get 6 again. If I get 6, I return it, and then I could get 8. And then this, possible selection of size 2, there are 25 of them that's being displayed on the screen. So now that I'm interested in their mean, a mean is about adding the 2 value and then you divide by 2 in this case, because there are 2 observations. So if you add and divide, these are the possible means that you can get. 6 and 6, 6 plus 6 over 2 is 6. 6 plus 8 over 2 is 7. But 6 plus 8 is 14. Divided by 2 is 7. And then you have them. And you can have 14 and 14. The average is 14. So you have these 25 possible means that you can get. Remember, size 2. 2 numbers out of 5. Now, if I put all of those together in a frequency table, that means my possible means with the number of possibilities, the counter, the frequency. What I have on the screen is what you will get. Because if you check from here, how many 6 are there? Only 1. But number of 7, there are 2. Number of 8, there are 3. Number of 4, the number of 9, there are 4. And the number of 10, there are 5. 11, there are 4. 12, 3. 13 is 2, and 14, 1. And that's where I got this figure from as the frequency. Okay? So from there, you can calculate your mean. So we all know that summation fx all over summation f is actually the formula for mean. So you can use that to find the mean of mean, and I'm sure you will get an answer. Because this I'll give you to go and work on and give me the answer in the next class. So before we move to estimation, let's go and select our sample using Excel. So I will stop sharing this screen, and then I will go to my Excel. So I'll stop sharing my screen. I'll open an Excel file and then share. Okay, so let me share this. Can you see my screen?
Yes, sir.
Yes,
All
sir.
right. So the tool that we need for our Excel, I want us to activate it from our add-ins. So you go to options, add-ins is there, okay? You go to options, you click on add-ins, all right? So you go to go here, all right? Then you check all the available options and then you click OK. So what you need is under data, and then that option or that module will have been activated. And in the module, we have sampling there, is there. Can you see my screen? Can you see sampling has been highlighted?
Yes, sir.
No, you can't see it.
Yes, sir, we can see it.
All right. So sampling is there. In fact, everything that we shall be doing, they are all here. Your correlation, your covariance, your regression, your hypothesis testing, one sample, two sample, this is your regression, and so on. Even analysis of variance is there. And
Prof,
over
sir,
test.
can you come back, sir? How you get to that from the Excel? You said add
All
in,
right.
then
So I said, yes, I said you go to your file, okay? From the file, you click options, right? So once you click options, the add-ins, they are in your, they are there. You click it. Once you click it, you need to go to go, so you can activate it. So when you click on go, you check all the checkables and then you click OK. So it will run for a while, depending on how slow your system is and depending on the version of your Microsoft Office. So once it activates, you will click, when you are on home, the options are not here. You click data. When you click on data at the top menu, to the extreme right, that's where you see the data analysis module that you have activated. That's it here. Once you click on it, these are some of the things that your Excel can do, which we will rely on for our course. And I said the option of sampling is there. Look at it here. Sampling is there, sampling. So this is what we'll be making use of. And then you click OK. So you can see that your Excel can perform periodic sampling. That is, you can see sampling method is there. This periodic sampling is the same as systematic sampling. Systematic. Remember what I said about systematic sampling? I said it is a sampling technique in which units are selected at regular interval. Regular interval, that is the period. Okay? At regular period. That is systematic sampling. It's the same as periodic in Excel. And you can also do random sampling. Remember our simple random sampling. So once you specify the number that you want, you select or to do the selection for you. So how many of us have activated our add-ins?
Sir, when I got to go, I click go. I didn't see the data analysis at the extreme right.
When you click go and stop scrolling, go to the top menu of your Excel.
Yes, sir.
You will see data there at the top menu.
Yes, I click the data.
Once you click the data, to your right, you will see your data analysis.
I saw forecast sheet. I saw outline. I didn't see data analysis.
No, it will be there. Let's go over what you did. Just watch my screen. Do you click file?
File, options.
Oh yeah. You have clicked file? No worry, let's take it slowly. You have clicked file, right?
Sir. Yes, sir.
And then you click option. Have you clicked option?
Yes, sir.
Are you seeing what is on my screen now?
Yes, sir.
All right. Then you click on add-ins. Click add-ins here.
Okay,
Have you
I've done that. I've done that.
All right.
Yes, sir.
No problem. Then you go to go here. Go.
Yeah, it's at the bottom.
You have seen it. Click on the go. Something like this will come. Are you seeing it?
Yes, sir.
Oh yeah. Did you check? Yeah, check. Analysis 2-pack. You're going to check.
Okay.
You'll be checking.
Is it that? So there is analysis 2-pack. There is analysis 2-pack VBA.
Just check. I said check everything there. Just check.
Everything. Okay.
Have you checked?
I've checked everything. Yes, I've checked everything.
All right. Yeah, click OK. Click OK.
Okay, I've clicked it.
All right.
Okay,
It's now running. Has it appeared now?
Oh.
Hello?
Yes, sir. Thank you, sir.
It has appeared. Okay. So who else is trying
it has.
Don't worry.
I've seen it, sir.
Don't worry. We will use it.
I've seen it. Thank you, sir.
Who else is trying it? Madam Sheung, have you tried your own?
I've not tried it, sir. My system, I had to restart.
Okay. Please restart you.
Before we close, I will try I'm on the road.
When you get to try. Madam Uraola, are you trying your own? Precious, are you trying?
Yes, sir, I'm trying it, sir.
Yeah, you will use it in the exam. Oh.
Okay,
So,
sir.
Madam Esther, are you using it? Mr. Alabi, Ahmed Bakari, Mayowa, Makinde.
Sir, we're trying.
Okay. So, we'll stop there for today. But I want you all to have the tool. And then next week, we shall do our sampling. Next week, we shall do our estimation. And then we shall do 1 sample test, 2 sample test, everything in Excel. You have learned all the formula. My job here is not to be teaching you all those summation X over N. You have done them before. I will just show you how you can use this Excel to calculate and then take some decision. So on that note, I want to appreciate you for joining the class. We shall see next week. Bye-bye for now.
Thank you, sir.
Thank you, sir.
Our results, sir, we have not seen it.
You said you have
Our
not seen
results,
it?
sir.
You have not
Yes.
seen it? Oh yeah, let's do it. Let's do it. Oh yeah. So oh yeah, start from file. Have you clicked on file? Let's start it. Click on file.
Hello, sir.
Hello, yes.
No, I'm referring to our last semester results. You said we're going to see two out of
Okay.
it.
Yes. I've asked Akim to share the results. He went to defend his thesis, so I think he's happy now. So he will use all your results.
Okay, thank you, sir.
All right. All right. Bye-bye.